All right. Welcome, everyone, to our panel on the shop system. So with us, joining us today is Scott Andrews, president of Impact System Engineering, professional engineering services firm, working with a very diverse array of engineering manufacturing companies based in Texas, but I think helping companies all around the world. We're also joined by Patrick Chouvet, CEO of EAC Ornement Métallique. I don't know if else that is, but a luxury goods leader based in France. And Chris Weirman, Director of Technology at Wall Kalmanoy, a world leader in material science, metal coatings, precision engineered components. So a lot of different applications, use cases, industry segments represented here. And let's see, I'm just going to stop sharing this one. All right. So let's jump in. We'll start with Chris. What are you hoping to achieve with additive manufacturing?
Hi, Ilya. Thank you. Yeah, additive for us is a bit of a journey. So we're looking for new options. I think a lot of people know our business, maybe for metal powders, certainly that factor into the additive manufacturing industry. For components as well, and we have a significant past opportunity here in South Wales and in America as well. So additive manufacture fits our product mix and our sort of ethos very, very closely. So we see a significant number of our parts fit the build envelope of the shop system, and certainly the complexity and the sort of wall thicknesses, they fit quite closely with additive. But that's for part manufacture, but we've significantly got our eyes on some R&D development as well. So we have process tooling, which we're really excited to be testing, and they will take our process to the next level and offer some significant advantages in our powder manufacture. And those tools can only be made by an additive manufacturer. So we're really keen to get the shop system working and delivering these tools for us to try.
Terrific, thank you. Scott, you want to share your perspective on what are you hoping to do with metal 3D printing? I know you've had a polymer based business for many years, and you just started with metal with a studio system.
Oh yeah, absolutely. So Impact is an engineering firm that designs parts for others. We do analysis of those parts. We have been basically in love with additive for many, many years. We've used it as design verification, and then we've seen our customers transfer to production through additive in the polymer world. So we want to see and take those customers on the same journey in the metal world. And we really see the beginning of that happening with the shop system. But that's our belief, is that this is a new alternative of manufacturing for our customers, and we're happy to help them get there.
Terrific. And Patrick, what are you hoping to achieve with additive manufacturing?
We are in the luxury industry for many, many years, and always been trying to manufacture and produce creative pieces, new kind of designs. The designers of our customers are always seeking for new shapes, new designs, exclusive, customized items. And we are fully integrated, so we are dealing with casting, lost wax, or stamping. And I was just waiting for the 3D printing to be possible, because the customers are always frustrating because they couldn't go as far as they wanted because of the prototype situation of the 3D metallic system till now, till the shop arrived on the market. So everybody is very exciting now to develop the design they really want to develop because of this new technology.
Got it. Thank you. Chris, what benefits is Wall Kalmanoy? What benefits are you seeking for your customers, for the business? Is it new geometries? Is it supply chain impact? Is there a customer service aspect?
So we've seen quite an increase in the number of inquiries we get in, Ilya, for parts that they can be manufactured via investment casting, but quite often the number of parts is quite low. Potentially the tooling cost is quite high to be able to deliver those parts. So that's almost a difficult sort of economic inquiry to take on board. So we see additive being able to deliver either the tooling that can still result in an investment cast part, or potentially with the shop system to provide the parts completely via additive manufacture. So certainly when we see that sweet spot of sometimes complexity, but certainly low number of parts and tooling costs, we see additive as a key sort of function for our business to go forward and claim those inquiries that might be deemed not profitable historically. There's a big change for us.
So if you're thinking to or producing parts today via casting, what's the advantage? Let's say a new part comes in from a customer to be cast. What's the advantage of kind of the two methods coexisting?
I think we saw earlier the amount of time it takes sometimes to deliver an investment cast part. So we have to obviously understand the customer's the design requirements, prepare tooling to make the lost wax process start off. And sometimes there's a time delay in doing that. These things don't sort of just appear overnight. I think we saw up to about 4 months earlier in the webinar today for turning around an investment cast part. I think we can do it a little bit quicker than that sometimes, but it does depend on complexity. But certainly, some of our inquiries mean that we have to turn those parts around a little bit faster than fits with maybe existing production planning schedules, and additive can shortcut that. Certainly in terms of supplying the first off parts, when investment casting is gearing up to deliver the bulk of an order, investment cast can get something to a customer within a number of days.
Got it. Thank you. How about Patrick? You mentioned being able to create geometries that you can't create any other way. Is that the primary benefit you're seeking? Are there other customer benefits, business benefits you're hoping for?
Also the fact to go faster, to sample and introduce to the customer many solutions, many designs, and in the marketing meeting they can choose the one they prefer without investing in the tooling, without waiting too long for the samples. So we have been developing some tricks with resin 3D printing and plating in metal the resin to save time and to show the product, but it will never be as nice and as heavy as real metal pieces. So that's the main advantage, because right now when we are developing new designs for a customer, till now we had to make choices before the customer could really see the piece physically on the final product. Right now, with these many possibilities, we can put many various shapes or designs that the designers have been choosing. We can develop them. They can put on the bags of Vuitton or the clothes of Chanel. And in their marketing meeting, they can decide which one they want without wasting time. And today in the luxury industry, time is money. They want to go faster and faster, to be always the first one on the market to introduce new series, new shapes. So that's the key for the future.
Okay, so time to first article, having them in your hands.
Exactly.
Okay. How about you, Scott? What's
So I agree. I agree very much with Patrick. It's rapid design iteration that's the primary advantage, and I think it's the reason many people go to metal additive. Then the ability to produce parts for a reasonable cost, and finally the ability to take that into low volume production. All three of those are important, but it's those design iterations that really helps that customer finish up that project in a very timely fashion.
Thank you. How not all parts are ideal to print. How are you thinking, Scott, about where does it make sense to actually apply 3D printing versus additive manufacturing versus stamping, machining, casting?
So additive fits very well in parts that would have traditionally been cast, both sand cast or injection or investment cast. So that was probably the first parts we've transitioned that direction. We've also redesigned some stampings to make them fit the additive process a little bit better. Sometimes they're too thin or the geometry is not appropriate at first. But those are the two easy transitions. Machined parts in many cases are probably better left machining if a customer is already doing it. So there's not just an automatic transition for every part out there, but casting probably fits best.
Casting, we've seen a ton of, but you're also talking about stamping. I'm curious, what's the aspect of why additive? How is additive manufacturing the benefit in stamping? Like, is it that the stamping's got some meat behind it, and you don't want to create the forming tools or progressive dies for it? Why is additive a win?
So it's a win for easy creation of the geometry, certainly. In many cases, those dies are used, very short period of time, and then they need to be changed or iterated. Additive fits great for that.
Got it. So casting, Chris, how about you? What are the first parts that you're thinking to produce via the shop system? How are they made today?
As I said, the first parts that we would like to make are the R&D parts. So we know that they can't be made today. So they've been designed theoretically. They've been designed with part freedom in mind, and we see that as a big change in the industry, where a lot of the opportunities that come to the business. I say a lot. Certainly in the last few months, we see now the threads of engineers sending in designs that can't be made by a traditional machinery, can't be subtractive engineered, very difficult to investment cast, and would need some subsequent machining. And we see an increase in parts then that are obviously made and designed by engineers with design freedom, without maybe some of the traditional machining skills or knowledge on board with them, and thinking, well, why can't I make that? I can conceive it in my head. Why can't I have it? And additive manufacture delivers that for them. So we certainly need to see that the world is going to evolve this way. Every year that engineers come out of college, they're going to have these desires and ideas to make things that they formulate in their head, and that's what additive can do for them.
Perfect. Thank you. How about Patrick? EAC produces a great deal of parts today. How are you going to prioritize and select which parts, which designs will be printed first?
It will mainly be the designs we are creating ourselves, because the main problem right now is to teach the designers and to make them understand that the sky is the limit. They are not used to design 3D pieces. They don't really understand right now what makes the difference between a 3D piece and a normal piece that you could do on a stamping or casting. Most of my customers are exciting with the shop arrival, but I don't think they realize what really can be achieved now with this technology, especially the binding jetting. So first of all, we will use the machine to go faster, as I was explaining. And then if the customer are not creative enough, we will try to convince them with our own creativity. And if they are still not creative enough, we will maybe use the shop for small series, for limited editions. But we will probably move to casting or stamping if the volume are getting bigger and it's not necessary to use a shop system to produce a classical piece. So that's the deal.
Can you share a little bit on the kinds of numbers, like pilot production run might be, is it 20 pieces, 100 pieces, 1,000? What are small, large, medium quantities that you might produce, and where the shop system might fit in relative to other processes?
I would say that till 3,000-4,000 pieces, we might use the shop system to avoid the investment in tooling for casting or tooling for stamping. Although if it goes bigger than that, I think it will not be worth, especially because we will then have a problem with production capacity, because we cannot, even if the shop is very fast and quick, we still have to improve the rest of the production system, the depowdering and the cooking. So I would say 3,000, 4,000.
Got it.
Maximum.
So I'd love to hear from each of you. You know, there's for somebody who's in the market looking to get a binder jetting solution, number of players out there, not just Desktop Metal. What are the criteria that you would recommend people consider when choosing a system? Scott?
Well, critically important to us was a complete system, to have a furnace that played well with the printer, and some experience from that vendor with the sintering process. We really saw that as the most complex and challenging part of the process when we started with metal in general. But complete system, and then of course cost and volume of production is equally important.
So volume is throughput, is that what you mean?
Throughput of the machine, yes.
Got it. And when you say cost, is it system, capital equipment, and like facilities costs, or do you mean per part cost, or?
So probably most important is per part cost for manufacturing. And then for a one-off production, of course, it would be the cost of the equipment.
Got it. Chris, how about you? You guys are early in your journey, and these are the early days for all of us. How are you thinking about when you're looking at binder jetting landscape?
The sort of key criteria that I was looking for, and the company ended up going for the Desktop Metal shop system, was what Scott said, really, in terms of build volume. That was key for us. The overall price of the system, but the main point for us really is the integrated nature of the system. Rather than having individual parts that we have to either have separate warranties on or separate knowledge of. Basically, we've got a system that you click a button and it does the rest for you. And we saw with the live sinter part of the webinar today, you know, Desktop Metal is holding our hand through all of this. So I think we're having a very low risk investment opportunity here in again, the shop system on board. And we've got confidence that the parts will be produced within days of switch on. So very key for us.
Perfect. Thank you for sharing that. Patrick, you've spent at least 4 years, if I understand correctly, looking at the entire landscape, studying it in detail. Can you share with us a little bit about your journey as you looked at the different systems, the capabilities, the requirements, and how you made your decision?
Yeah, I started 5 years ago to be interested in the 3D metal, and I was very disappointed because the technology that were existing at that time were a little bit the same system than on plastic, with supports. And supports in metal in the luxury industry are a big problem, because you have to cut the supports, you have then to polish the supports, and it's a big investment in time. And the look were not really nice. So I've been pushing and searching and finding Digital Metal in Sweden that were launching this binding jetting system. And that was for me this is the one for luxury, because you are printing without support. So when the pieces are ready, they are more or less like they will be at the end of the production. So we had to develop some polishing system to perfectly polish the pieces when they are out of the furnace. And then, since we are also plating the pieces, the polishing was a very, very important aspect for the final aesthetic of the product. And for me, with my knowledge today, only binding jetting is allowing the pieces to have a perfect look at the end, without having to hand polish or automatic polish the pieces, which is always a big problem if you have supports. I can see it with the plastic printing on machine. It's great, but when you have to take off the support and polish the bad aspect of the support, it's a nightmare. So this was the main reason why the binding jetting for me is a revolution.
Thank you. How about Scott? Let's as you look at what the systems can do, and with the way you've seen engineers bring products to market, how do you see this technology change the kind of the design, manufacturing, maybe aftermarket process? Does it change it, or is it just is it something that plugs into an existing process?
It is absolutely a revolutionary change. The only issue is that we see many parts that are not designed for additive today. I think in the next few years we'll see more and more engineers, and I think Chris, you touched on this, that more and more engineers are learning design for additive, and they're starting to produce designs that really take advantage of additive. The hardware systems work great. The engineering and maybe the education of the engineers can improve a little bit so that they do a better job knowing what capabilities are out there.
Thank you. Chris, how do you view things? It sounded like getting samples, maybe the process of getting parts, requests for proposals, and getting samples to customers, that could be impacted, or maybe time to first deliveries can be impacted. Beyond that, are there aspects of the engineering and manufacturing process that may change?
We've got a number of different sort of processing options here, and obviously customer specifications are their own and unique, and surface quality, surface roughness, we have to match those. So yeah, it's certainly interesting for us to be able to understand what the surface condition is. We certainly see that parts that we can make through the shop system have an equivalent or better surface roughness than an as cast part. So we do have a significant amount of parts that leave the business as cast without any subsequent machining. So we know that those processing routes through AM can be a direct feed into the market through existing customer channels. But certainly we would see that there would be a need for some surface polishing, some machining to get to the lower RA values that some of our customers need.
Got it. So what kind of surface roughness are they used to, or do your applications need? Because, for example, a lot of binder jetted parts might be 3 or 4 micron average surface roughness.
Yeah, typically less than 1. Certainly for a machine component, a bit less than that. But it does depend on the customer and what the job of the individual part needs to be. But we end up CNC turning a lot of parts within our precision components division. We tend to get down to less than 1 RA without any difficulty really, and that's with some really tough alloys, some cobalt and some nickel-based alloys. Yeah, we've seen RAs down to 0.2, so we can do some lapping as well. So get very high surface quality if needed.
0.2, so just a couple hundred nanometers roughness.
Yeah, right.
Yeah. Okay. Without super finishing or anything, it's just from the turning or machining.
And lapping, yeah. So we do some surface finishing on it, some honing sometimes, but yeah.
Terrific. How about Patrick? Your perspective on does additive, is it just a more efficient way to produce something that you already? Does it plug into an existing process, or does it change how you bring parts to market?
At the beginning, it's going to be a complementary, because again, we need to teach and to make our designer think differently. So for me, with the stamping, the die casting, the lost wax, now the bending jetting, this is one more department to give the opportunity to our customer to produce the pieces they want on their product. I think that the more the designer will be aware of what's going on and what's coming in front of them, the more they will be willing to use the the binding jetting, because it's opening crazy doors and crazy, there is no more limit for creativity. That's the reason why we are designing, and you saw some of the pieces we are doing, more and more crazy pieces to show the customers and to convince them it's ready, they can use it, it's coming. They just have to design, and they just have to ask us to produce the piece of their dream. So at the beginning, it will be complementary, but as soon as possible, I think it will be the center of what the luxury people will ask for their small series and their customized item they want to produce and to put on the market, to create the events and to create the exclusivity. This is what people are looking for now.
Terrific. Thank you. How about Chris? I know these are the early days, but if you had to guess what the next, maybe not 10, but next 3, 4, 5 years might bring in terms of pushing the envelope. I know you guys do a lot of work with materials, with different kinds of parts. What's your kind of wish list / forecast of where the technology is going to go and what kind of things will be possible? You hope will be possible.
I think we've seen a little bit today that there's other opportunities out there. There's other alloys out there. There's a significant amount of alloys in the world that can lend themselves to binder jetting. So I know that 74BH is a firm candidate in the shop system, but there's others we can choose as well. And certainly taking the shop system and its clear sort of competitive edge in the speed that it can deliver parts to new alloys and new designs. Certainly with other sort of functionality that we can offer at Wall Colmanoy, like blended alloys, we could certainly look at how the systems will develop, and that's without the development of speed and build volume and resolution that I'm sure will come over the next 2 to 3 years. So it's interesting to see what the journey's got ahead of us.
Thank you. Scott, how about your take? What's coming? What do you hope is coming?
Two things. More alloys. I totally agree with that. And then automated post-processing, especially in any areas that have metal powder contact, to both reduce labor cost and increase safety.
Terrific. All right. Well, I think we've covered a lot of topics in the last 30 minutes, and I really am grateful for everyone's time. And Chris and Patrick, I know it's a little late where you are, and next time we promise we'll do this at a time even more convenient for Wales and Paris. I want to thank Scott and Chris and Patrick for the session, and
thank you for the invite, Ilya.
A lot of fun in your journey. We'll be here, of course, to support you, and we'll all learn together.